didn't specifically go over vocabulary words yesterday, but this will go over the most important words that you need to know for this week. So from chapter 9, erosion, as you guys mentioned, the movement of weathered particles by natural forces. And that includes things such as gravity, wind, water, last week we talked about weathering, which was the breaking down of rocks into smaller particles. Erosion is the movement of those particles to another location. And we've talked about much of this over the last couple weeks. You can see you have wave action and ice eating away here. So the cliff is being worn away. You have water and waves wearing it away here. Here we have floodwaters in the field washing away silt. And here's something we see a lot here too, flooding that's eating away at this hillside. And here in Colorado, one of the huge problems we have with erosion is when we have forest fires, it burns down all the trees and all the ground cover. And so then you're left with exposed slopes. And then when you get snowfall and rainfall, it is all washed away and causes quite a bit of erosion. Next, deposition. So again, just like the word suggests, erosion is where it's moved, and deposition is where it is deposited or left someplace else. And so again, we see here evidence of deposition. Once things are eroded, the sediment is being carried somewhere. And here, you can see it almost looks like kind of big tracks, like from a road grader or something. This is actually erosion from a glacier. And you get huge rocks sometimes just left behind from a glacier, and this big flat area. So this is an area where a glacier moved through and deposited the rock, usually lots of little stuff, and sometimes those big rocks sitting out in the middle of nowhere, which are called glacial errata. Here, this is, we'll talk about this a little bit later. You can see that the water has come down through the mountains here, down the canyons, and made what's called an alluvial fan, which we'll see in one of the other slides as well. And here again, you've got flooding, you've got erosion here, and you can see where the sediment is being deposited other places. Okay, one of your vocabulary words is continental divide, which is kind of interesting because for many people it might just be a word in a textbook, but for us, continental divide is something that you can see and something that you can visit quite closely. And a continental divide is just what it suggests. It divides the continent, but more specifically, it separates the watersheds, which way the water flows into which oceans, or which rivers and oceans. And the continental divide, a divide in general, I think that says divide under there, a divide in general divides the water going to different watersheds. The continental divide divides if the water is going to the Atlantic Ocean or the Pacific Ocean. And so you see here, we have many places in Colorado where you can go see the continental divide. Right here it says Atlantic Ocean drainage. The Cashlaputer Creek drains into the Platte River, which flows into the Missouri, then to the Mississippi, then reaching the Gulf of Mexico, which is part of the Atlantic Ocean. And then up here, the Pacific Ocean drainage. Beaver Creek drains into the Colorado River, which flows through the Grand Canyon National Park onto the Gulf of California and onto the Pacific Ocean. Yeah, the Gulf of California, that's between Baja California and Mexico. All right. And it's interesting too, though, even though you go up to the mountains, you see the 14,000-foot peaks, they may or may not actually be part of the continental divide, depending on the rest of the land. Try it again. Floodplain is our next word. The floodplain is the flat, wide area along the river, and it's underwater during flooding, which again might seem fairly obvious, but it turns out oftentimes people build homes here. They build their home down near the river. you can see here, this is a river that's flooding. The river isn't usually this wide. Up here you see some buildings. They're way up here. When these people built these buildings, they said, oh, the soil's good here. We're near the river. We can get water. But they might not have realized that not on a regular basis, but occasionally the water will come way up here. And that's part of the reason why the soil is good, because it floods. You get the silt that lays down nice soils for farming. Here again, you can see very clearly, even though the river is only down here, this whole flat area is floodplain. This whole area here is floodplain, even though the river's just here. And this is what's called a meander in the river. The river has eroded away and become very curvy, but all of this area in the middle is subject to flooding. And now, alluvial fan. This is one of my favorite ones because it's a really neat, obvious feature. And you can see where, again, from the mountains, you see the water coming down in this little channel, and it might trickle down just a little bit now and then, but in times of flood, you get this whole area. So you can see this whole huge area that's the alluvial fan, which is a wide sloping deposit of sand and sediment where a stream leaves the mountain area, and it's fan-shaped. And this is kind of interesting to me because you can also see there's kind of this coast road going along here, and I'm thinking maybe sometimes it might be a little hard to keep that road clear. But that's an alluvial fan. A similar feature is a river delta, and river deltas are basically the same thing, except it's where a river comes out and then generally into the ocean. This picture actually isn't very great resolution. This is Louisiana. So the Mississippi comes out, and for hundreds of thousands or millions of years has been dumping water out there, and every time it pulls a little bit more sediment, and it actually builds kind of a finger of land out here. And because it's near the ocean, it's a good area for transportation. People build cities and stuff in areas like this, but it's very close to sea level, and what happens oftentimes is the sand and earth and stuff there is not very stable. Glacier. Here's another feature that we see here in Colorado, or we see evidence of here in Colorado, that in other parts of the world might be something you just read about in a textbook. A glacier is a large sheet of snow and ice that is actually moving very slowly. And what's happening is it's a massive sheet of ice and snow, and the pressure of it actually melts the bottom lower level, which kind of gives it a little bit of something almost to float or move on, kind of breaks down the friction. This one I like because you could almost imagine all of this snow and ice is just pouring out of here. That's a very awesome looking one. In pictures up in Alaska, you can see lots of images of this sort of thing. There used to be more glaciers around this area in the last ice age. Up in Estes Park, areas like that, there's evidence of glaciers. And again, it literally looks like a river flowing, but it is so massive, it creates very large features. And when you're not in an ice age, the glaciers retreat, which means they melt faster than they form, and then you can actually see some of the landforms underneath. Related to a glacier is a moraine. Again, up in Estes Park, there's actually an area called Moraine Park. Moraine is a glacial feature, the deposition from a glacier along the sides or at the end. Oops. If it's along the sides, it's a moraine, and then a lateral moraine, and a terminal moraine is at the end. And again, you see here the glacier moving down these channels, and you can see where it's melted back, and you can actually see the ground here. This one right here, again, fairly easy. The lateral moraine, which is on the sides, looks like it just bulldozed up there, and the end, or the terminal the terminal moraine here. And if the glacier starts melting more than it forms, you'll end up with that kind of odd-looking wall there. And we saw pictures in the first couple slides of the flat, almost bulldozed-looking areas. But they do actually carve canyons, as you can see, and make what used to be little canyons or valleys much bigger and broader. Sand dunes. Sand dunes are the deposition of sand, and it's generally caused by other features such as mountains. We learned in our lab last week that sand, a little bit of sand in the water, a little bit of sand in the wind, really accelerates the weathering and therefore the erosion. It acts very abrasive, like sandpaper, and causes a huge amount of more erosion, more and more erosion, the more sand you get into things. And once again, here in Colorado, we have an awesome example of sand dunes, the Sand Dunes National Monument, if you've been there. And the very interesting thing about the Sand Dunes National Monument, it's surrounded by mountains, and it's down in southern Colorado. Kind of not a place you'd expect to see sand dunes. But the way the winds blow and the way the mountains are around on many different sides, the winds blow around the mountains, and then they settle right there, and the sand falls out of the mountains, or out of the wind, and forms these sand dunes. Here's another picture. Looks like it's probably Utah or somewhere like that. Sand dunes. And of course, you do get sand dunes near beaches and deserts and places like that as well. Energy that moves. Tomorrow and Thursday, Friday, we're going to be looking at stream tables. Also, when we go to the museum, there's a big stream table in the space exhibit. This is a little bit of a review from 6th grade, as we've talked about having these connections back to 6th grade curriculum. There are two types of energy that moves things. You have potential energy. Potential energy is higher when there's the potential to move. It's stored up energy. So water at a higher altitude, high in the watershed, with a long way to move, has more potential energy. If you have a tremendous amount of water built up behind a dam, it's a huge amount of water energy stored up, and so that's potential energy. Potential energy is stored energy. If you compress a spring, that's potential energy. If you stretch out a rubber band, that's potential energy. Then kinetic energy is the energy of moving. So a fast-moving stream has more kinetic energy than a slow one. More water is moving is more energy. So a tremendous amount of flood water, more kinetic energy. More kinetic energy moves more and bigger sediments. So that spring you had compressed, when you let it go and it flies across the room, that's kinetic energy. When the kinetic and potential energy decrease, the sediment falls out and is deposited, which might sound confusing, but it's very common sense. If the water's moving really fast, total flash flood, moving lots of stuff, that's a lot of kinetic energy. When that same water gets out to the plains, gets out to flat area where it spreads out, the water slows down, all the silt and rocks and trees falls out of the water. As we look at our stream tables tomorrow, you will make note of where there's more and less erosion, which is, of course, related to the energy of the water.